Hello, pre-calculus. It's Mrs. Applegarth. Happy Friday. We're going to talk about slant or oblique asymptotes. Our learning target is to find slant or oblique asymptotes of a rational function. We spent the first few sections in this unit going over vertical asymptotes, horizontal asymptotes, and now we have a slant asymptote. Okay, so let's do a little review. When the degree of the numerator is bigger than the degree of the denominator, so when the top is bigger than the bottom in a rational function, there is no horizontal asymptote. Instead, they have a slant asymptote. It's also known as an oblique asymptote. In order to find the equation of the slant asymptote, we have to go back to dividing polynomials. We can use long division or synthetic division, but we can only use synthetic division while we are dividing by a linear factor. So that is like x minus 2, x plus 7. So it has to be a linear factor to use synthetic division. All right, so let's take a look at the scenario. Find the slant asymptote for the function f of x equals x squared plus 2x divided by x minus 1. I'm going to go ahead and use synthetic division. So we're going to start with the second degree. So in my synthetic division, it's going to be 1, then 2, and then I don't have a 0 degree, so I'm going to put 0 in for that. Remember, for synthetic division, we use the opposite of what we're dividing by, well, opposite of what's with the x. If it's given to you as a 0, you just use that number, but if it's in the x plus or the x minus form, you use the opposite. So we're going to use negative 1. We put our coefficients 1, 2, and 0. We're going to drop down the first number, and then we multiply and add. Negative 1 times 1 gives us negative 1. 2 minus 1 is 1. Negative 1 times 1 is negative 1. 0 minus 1 is negative 1. We are going to take, and we're going to ignore the remainder. So to find the oblique asymptote, we ignore the remainder. And then we just take the 1 and the 1. And we go, okay, we divided, so we started with an x squared. We are now going to have just an x, so that is 1x, and then plus 1. And this is the oblique asymptote. So what does that look like? So we're going to graph this. We're going to find the vertical asymptote, the x-intercept, and this is good practice, you guys, for your Module 5 test because it has all these values. You have to find all these values for the graph anyway. And then we already know that the oblique is at y equals x plus 1. Okay, so the vertical asymptote is when the denominator is equal to 0. So that's when x plus 1 equals 0. So then we subtract 1, x equals negative 1 is the vertical asymptote. The x-intercept is when y is equal to 0. So that is when our whole function is equal to 0, not the bottom, but just the top. So I'm going to take my top, set it equal to 0. It factors, and I find my x-intercept. I'm going to write it to the left here. The x-intercept is at 0, 0, because x equals 0 is at, when you have just an x by itself, x equals 0 is the solution. And then it's the opposite of plus 2, so it's at negative 2 comma 0. All right, and then the y-intercept is, we're going to have, it's in our function when x is equal to 0. So it's going to be 0 squared plus 2 times 0 divided by 0 plus 1. That ends up being 0 over 1. So the y-intercept is at 0, comma 0. Yay. That makes sense. Okay, so let's put those all together on our graph. So our vertical asymptote is at x equals -1. So we're going to put up the wall there. And then our x-intercept is at 0, comma 0, right here, and at -2, comma 0, right here. And then our oblique asymptote is at y equals x plus 1. So that is a slant line. We're going to start at 1. And it's going to go up 1 over 1. So it's going to look like, it's an asymptote, so let's draw it. Let's draw it like a wall. All right, so let's see how this is going to look. I'm going to draw it. Let's draw it in green to stay consistent. So it's going to follow this asymptote line, come up, and end up following the wall at -1. Then it's going to start low, follow the wall at -1 from -infinity, hit the 0, comma 0, and then follow the slant asymptote all the way up. It's like a skinny little guy. Love it. Okay, so we're going to do some problems here. We're going to find the slant asymptotes for these functions. So we have 2x squared plus x. We're going to factor this out. Actually, no, let's not factor it out. Let's put a plus 0 here. And we get -1 in the synthetic division. As long as we have a linear function, we're not going to be able to do it here. So I will show you long division on the second one. But then we have our coefficients are 2, 1, and 0, because we don't have that 0 degree on the end. Okay, so we drop down our first one, and we multiply and add. -1 times 2 is -2. 1 minus 2 is -1. -1 times -1 is 1. And 0 plus 1 is 1. We're going to ignore the remainder, and then we get y equals 2x minus 1 is our oblique asymptote. Our vertical asymptote is when our denominator is equal to 0. We had that in the last problem, so I'm just going to snag it from the last problem. Our x-intercepts is when our top is equal to 0. Put that over here. And I'm going to factor it out while I'm here. X parenthesis 2x plus 1. So our x-intercepts are at zero comma 0, and it's when 2x plus 1 equals 0. So minus the 1, minus the 1. So x equals -1/2. My y-intercept is at 0 comma 0. Right, so I'm going to put our important numbers on Um, so let's put all these on. I'm going to switch colors so we can see a little bit better. So we have a x-intercept at 0, 0 and negative 1/2, 0. We have a vertical asymptote at x equals negative 1. And a slant asymptote at 2x minus 1. So you start at minus 1 and you go up 2 over 1. So we end up, let me just move this guy. We'll just do it in blue. So we end up having a little buddy like here. Oop. And then this one comes here. Super fun. Little swoopy. I love it. Okay, so we're going to look at some long division over here. You guys are going to love this. We haven't done long division together, so bear with me. So we put the guy on top inside. Top dog goes in the house. We make sure we have something for everybody. We have a cubed, a square, a 1, and a 0. And then this is x squared plus 0x minus 4. So we're going to do some long division. How many times does x squared go into x, or what do I need to multiply x squared by to make it x cubed? The answer is x. So the x goes on the top. Get it to draw. X goes on the top, and then you multiply all of your guy on the out front by that x. So that's going to be x cubed plus 0x squared minus 4x. And then you change the sign of everything. Negative, negative, positive. So these cancel and get 0. Negative x squared minus x squared is negative x squared. 2x plus 4x is 6x. And then we bring down the 3. Then we go, what do I multiply x squared by to get negative x squared? That would be a negative 1. And then everything here gets multiplied by negative 1, so that's negative x squared, negative 0x, positive 4. And then we change the sign of everything. Negative x squared plus x squared is 0. 6 plus 0x is 6x. And 3 minus 4 is negative 1. And then so we ignore the remainder and we just take the guy on the top. So our slant asymptote is y equals x minus 1. Okay, let's look at our asymptotes are going to be at x minus 2, x plus 2. We're going to put all those pieces on our graph. So we have at negative 2 and 2, we have the wall. And then we have a slant asymptote at y equals x minus 1. So that starts at -1 and then goes up 1 over 1. And then it says use your calculator to show a sketch. So we're going to take a peek over here. We're going to punch in x cubed minus x squared plus 2x plus 3 over x squared minus 4. We take a look, it's got a little John Travolta in the middle, and then it follows our slant asymptote. So let's go ahead and add that to our graph. We have asymptote here, little slant asymptote, one up here, and then a little John Travolta in the middle. Okay, back to, we're going to do this will be fun. We're going to tackle some long division again. Actually, let's not do long division. Let's do synthetic division. Or do you want to do which one do you guys want to do? You want to do long division or synthetic? Oh, okay, let's do synthetic division. So we're gonna because we have the linear, we're gonna take the -1. We cubed, squared, x, and then 0. So I have 1 for each of us. We drop down the first one, multiply and add, multiply and add, multiply and add. Okay, and then we ignore the remainder. So we have got our slant asymptote is at x squared minus 10x plus 37. Oh, that's a little parabola. How fun is that? Okay, so to find this, you guys, I want you to set your windows to -10, 20 and -100, 200. So that's going to be a new window situation. But it's going to end up being a parabola. And let's take a peek at what that looks like. No, not what I want. All right, so our top ends up being -x cubed minus 9x squared plus 27x minus 27 divided by x plus 1. Okay, and then they said set our window to -10 to -20. Sorry, -10 to +20. And -100 to 200. And then you can see it. Oh, look at this little swoopy. I love it. So here's our parabola asymptote. Kind of swoop in this way. How fun. All right, let's draw that on our paper. So we have a little swoopy guy here. And then a little John Travolta, whoop, but we come up here. How fun is that? All right, you guys, that's a lesson for today. You guys are now on to your practice test. Enjoy.